Hi all, so today we are going to be talking about dilations. And a dilation is a transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. Usually it's the origin 0, 0. In this picture you can see that the red figure has either been enlarged to become the blue figure, or maybe the blue figure has been reduced to form the red figure. Either way, in a dilation, if you connect corresponding vertices, like if you think of this as a point and this as a point and draw a line through them, all of those corresponding vertices should meet at a common point, which will be the center of dilation. Okay, so if you draw lines through all of the corresponding vertices, they should meet at the center of dilation. In this example, you're asked to tell whether the blue figure is a dilation of the red figure. In A, what we would do is what I was just saying. You're going to draw a line connecting the corresponding vertices. And you see how all of these lines connecting, like the tip of the triangles, the lowest point of the triangle and the highest point of the triangle, when you drew lines connecting those corresponding vertices, it all met at a common point. That means the blue figure is a dilation of the red figure. In B, the blue figure is not a dilation of the red figure because they are the same size and the same shape. It's a translation. So B is not a dilation because they are the same shape and the same size, and therefore they are a translation, not a dilation. The blue figure is just a slide of the red figure. We did not change size. Okay. In a dilation, the original figure and its image are called similar to each other. Okay? Similar figures are the same shape but different sizes. They are actually proportional in size. We call it proportional in size. Their side lengths will all have the same ratio. If you look at AB, side AB, it's 2 boxes long. Side A prime B prime is 1, 2, 3, 4, 5, 6 boxes long. If you look at BC, it is also 2 boxes long. And if you look at B prime C prime, it's 1, 2, 3, 4, 5, 6 boxes long. So we're going 2 to 6, 2 to 6. So it's proportional, all right? We're actually just multiplying by 3 to get from one side length to the other. And that's what similar means. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is the scale factor of the dilation. Okay, so if we were going from 2 to 6, we would say that the scale factor was 3 because 2 times 3 is 6. To dilate a figure with respect to the origin, you're going to multiply the coordinates of each of those vertices by a scale factor of k, some number k. In this particular question, it was 3. We multiplied by 3. You take the x value and you multiply it by the scale factor, and you take the y value and you multiply it by the scale factor. For example, if you look at B, point B, that is at 2, 2. 2 times 3 is 6. So B prime is at 6, 6. It started at 2, 2. Now it's at 6, 6. We just multiplied the x and the y value both by 3, the scale factor. When that scale factor is greater than 1, the dilation gets bigger and is called an enlargement. When the scale factor is greater than 0 but less than 1, so we're thinking numbers like a half, a fourth, an eighth, fractions that exist between 0 and 1. the dilation will get smaller, and it's called a reduction. So here in this picture, ABC, triangle ABC is smaller than A prime, B prime, C prime. So it's a enlargement. We multiplied by a scale factor of 3, we said, and 3 is greater than 1, which makes the dilation an enlargement, which you can visually see. It obviously got bigger from the red figure to the blue figure. Okay, so now let's work on an example. I'm going to slide me over. Draw the image of triangle ABC after a dilation with a scale factor of 3. So this is how we're going to create what we were just talking about. And our first, I'll put me back up there now that the directions have been read. First step, you need to state what the vertices are of the original triangle. So A is at 1, 3, B is at 3, 3, and C is at 3, 1. We are told to perform a dilation with a scale factor of 3. So that means we're going to multiply each x and y value by 3. To create the bigger, we're multiplying by a scale factor of 3, so it's going to get bigger to make the bigger coordinates. So what you do is you take the original coordinate, 1, 3, and you multiply each value by 3 to get the new coordinate, which would be A prime is now 3, 9. B, we're going to multiply 3 and 3 by 3 and 3. So 3 times 3 is 9. 3 times 3 is 9. So B prime is 9, 9. And C prime is going to be where we take 3, 1, and we multiply the x and the y by 3 to make 9, 3. And then you graph those points. That's 3, 9, 9, 9, and 9, 3. Create your triangle, and then label your vertices. And lastly, we were asked to identify the type of dilation, and because the scale factor is greater than 1, we multiplied by 3, it tripled in size, and it's an enlargement. And that's your first dilation. Our second dilation, we are going to now draw the image of rectangle WXYZ after a dilation with a scale factor of 0.5, 1/2. And then we're going to identify the type of dilation again. I am giving you the rectangle already graphed, so our first step is to state what the coordinates are of the original rectangle. W is at -4, 4. X is at 4, 4. Y is at 4, -6. All right, in this next example, we are asked to draw the image of rectangle WXYZ after a dilation with a scale factor of 0.5, and then identify the type of dilation like we just did with the enlargement in the previous slide. Now, our first step is that we are going to state the vertices of WXYZ. W is at -4, 4. X is at 4, 4. Y is at 4, -4, and Z is at -4, 4. Then we have to think about the fact of our scale factor. Our scale factor was 0.5, which means we are going to multiply the X and the Y value of these original vertices by 0.5, okay? So to find W prime, what you do is you take -4, 4, and you multiply each of those values by 1/2, which is the same as dividing by 2. Okay, so 1/2 of -4 is -2, and 1/2 of 4 is 2. So W prime is now the point -2, 2. We just halved both of those coordinates. Same thing with X. Multiply 4 and 4 by 0.5, and you get that X prime is 2, 2. Y prime is going to be 2, -2, because 1/2 of 4 is 2 and 1/2 of -4 is -2. And then lastly, z prime is going to be negative 2 comma negative 2 because half of negative 4 is negative 2. Now all we have to do is graph. So we go to negative 2 comma 2 and we put a point, 2 comma 2 and we put a point, 2 comma negative 2 and we put a point, and negative 2 and we put a point. Then we draw our new rectangle. They are actually squares, which is a type of rectangle. And we label W prime, X prime, Y prime, and Z prime. And we say that this is an enlargement, okay? And identify the type of dilation. This is an enlargement because, sorry, now that we have everything graphed, we can see that the original figure, WXYZ, is bigger than the new figure, the image, W prime, X prime, Y prime, Z prime. And therefore, it's a reduction. The dilation is a reduction because the scale factor is greater than 0 but less than 1. Our scale factor was 0.5. Also, if you drew a line from the origin through Z and Z prime, we would see that the origin is the center of dilation, just like what we started with in our original examples. All right, that is all. Take care.